Bismillahirrahmanirrahim. Assalamu alaikum, dear guys. Welcome you all. This is Mr. Atiq from Science Department once again. We have week 12 physics chapter 14 section 2. Section 2 we discussed half of it, I think so. The pages that we are going to cover this week ranges from 492 to 496. 10 lenses, that was the chapter or the section name, you can see. Discontinued. Okay, the 10 lens equations and magnifications. I have a supplemental video for you guys regarding the 10 lens equation and magnification. Kindly do follow that thing. But first of all, you need to know the equation of the equation that relates object and image. Remember, object and image distances for a lens is called what? 10 lens equation or lens equations. Understand? Which relates to the object and image distances. Understand? Remember, focal length is always there within these equations. It is derived using the assumptions that the lens is very thin. Okay? To clearly give you an idea that the lens is very thin. The 10 lens equation and magnification. How to zoom the things. Look at continued. The magnification of a lens. Let me remove this continued word for you guys here. Yeah. Magnification of a lens depends on object and image distances. Remember this distance is okay. Remember that depends what? Object. Do you know the magnification is denoted by M when then in object height and image heights there. Okay, so follow the supplemental video for this lecture I will upload for this week. Now the thin lens equation and magnifications continue. If close attention is given to the given conventions defined in the table, look at, we have a table here, then the magnification will describe the image size and orientation. Where it will be placed, it will be negative or positive, it will be like real or virtual. It will clearly describes what. Okay, the magnification will be of what sort of circle. Okay, look at the P, Q and F respectively, image, like then the object, and then the focal length. Look at plus, always this plus sign will be used for what? Look at in the positive manner. Real objects in front of the lens for the P, okay, and negative, real objects in the back of the lens. Now Q, for the Q, the magnification will be what? Virtual image in the back of the lens and virtual image in front of the lens. Remember these back and front holes. And F is what? Converging lens. It's okay. F is what? F is here the converging lens, positive, and then diverging lens. We described already the converging and diverging phenomena in the previous lessons, like in the previous week. Eyeglasses and contact lenses. Whenever you are going to visit any shop, you will see two kinds of glasses there, so eyeglasses and then the contact lenses. Within the eyeglasses there is a certain portion for the contact to be implanted there. Okay, we call them what? Contact lenses there. Look at the transparent front of the eye called the cornea acts like a lens. Remember, we have a transparent eye front, we call them what? Cornea. It acts like a lens. Then the eye also contains a crystalline lens. Remember, the eye contains a crystalline lens as well in the middle, you can say, that further refracts light towards the light sensitive back of the eye called the retina. Remember the cornea difference and the retina difference. Okay, this is what retina mainly focuses all those things. It further refracts like the large area being covered through retina. Okay, whenever you are gonna to see some object in the light. Okay, so it is a light sensitive thing like retina. Okay, now two conditions: myopia and hyperopia. Myopia and hyperopia occurs when light is not focused properly. When light is not focused properly retina. Okay, two kinds of things can happen because retina is a light sensitive thing. So it cannot be focused properly to the retina. We call that factors like myopia and hyperopia. Look at hyperopia. Look at converging and diverging lenses can be used to correct these conditions. Remember, for the myopia and for the hyperopia deficiency, as far as the retina is not going to focusing them up very clearly if the light is coming back or like from the back or from the front. So we are gonna to we are just in that condition, we are using the converging and diverging lens in order to remove these two malfactors, okay, of the eyes. Look at far sightedness and near sighted. Okay, far sightedness, you can say far sighted and near sighted. Far what, like away, and then near sighted, like near to. Look at far sighted. These two structures relates to the far sighted, when the object is far away from you guys. Look at hyperopia. Look at far away, it is coming to you guys. Corrected with a converging lens, it will come what? It will, look at this is the converging lens. Converge, it will integrate all the far sighted area. We call them hyperopia. We are going to remove this thing by using the converging lens, okay, not the diverging one. Okay, now to brought up them all to the focal point, we are using what? The converging lens. Now for the nearsighted, look at two rays suppose are coming, or light rays. Look at corrected with the diverging lens. Corrected with the diverging lens, they are going to strike before here. Look at, it will not come to the original neuron, like to the original transmitter, which relates to your nervous system. Look at myopia, the two rays are coming, they are not focusing equally, or they will just strike with each other before going to the transmitter, okay, or the neurons to touch. Understand? Or the axon and dendrites here. Remember, these factors being removed through by using the diverging lens. Look at straight aerial one. Understand? Look at the two rays are coming. Look at this distance. Look at, it will come to touch this area. Look at, this is the axon and dendrites and nervous system area. Okay, now look at here the myopia factor. Look at, it is striking here, not gonna to touch or to focus to here. You got the idea? Now look at the focus point here as well. It is just away. Hyperopia, far-sighted. Look at, now by using the converging lens, it will come to the focus area. This one, look at, it will strike here. Look at the clear. Look at it, it is away here and it is focused here because we used what? The converging lens. So for the far-sighted and near-sightedness, remember these are just the two main factors. Understand? Two main factors. Okay, far-sightedness and near-sightedness. This can help you in your SAT exams as well, like the far-sightedness and the near-sightedness. Okay, for the far-sightedness we call them what? The hyperopia. If for the correction we are going to use the converging lens, and for the near-sighted area or for this factor we call them what? Myopian factor, and it can be corrected, or you can say by using diverging lens you can correct this factor or this deficiency. Now combination of thin lenses. I think this is the last one. Combination of thin lenses. Look at, an image formed by a lens can be used as the object for a second lens. An image formed by a lens can be used as the object for a second lens. Compound microscopes. Look at compound microscopes. These are the very highly zoomed and magnified things. Okay, compound microscopes. Got the idea? Okay, using two converging lenses, greater magnification can be achieved, like zoomings, all those things, clear view, better pictures, better pixels, like you can call them HD as well, like that can give you each and every site, each and every you can say like a small thing in a better and a classic way. Okay, magnification can be used for that thing as well, because it interacts with the object and images. So by using the converging lens, by making them two, you can achieve better magnifications by combining two or more lenses. Look at refracting telescopes are also used to converging two converging lenses. Refracting telescopes uses what? Converging lenses. Remember, and compound microscopes, that uses what? That uses two converging lenses. So this was all about, by the way. Now look at, we have a slide here for this thing, especially for this one. Look at, for the thin lens and magnifications, and for the thin lens equation magnifications. For these two and thin lens equation magnifications, for these two factors, I'm going to upload a video, a kind of supplemental video regarding the thin lenses. Okay, so you will better understand that thing there. Fi amanillah.